Thank you very much for your introduction. And I'm sorry, my voice is a little bit strange today. So first of all, good afternoon, everyone. And today I would like to present our findings from our post-flood field survey investigation in Vietnam and in the Philippines. So today I would like to show extreme rainfall and the hydrological response from the basin and the dam operation and the role of the local communities and the stakeholders interact to shape the flood dynamics on the ground. So these are the post-flood survey members, teams. So we conducted this in collaboration with our local partner between Kyoto University and Vietnamese partner, and as well as this is Da Nang University of Science and Technology, and as well as our partner, local partner in Philippines, Isabela State University Group. They joined force with Kyoto University DPRI research team. We visited 2 countries during almost 2 weeks or 2 weeks and something. So during the survey, we mapped several things. The watermarks, we had a questionnaire interview with the local communities and the stakeholders, and performed also before the flood or before going numerical modeling, hydrological modeling, and as well as we tried to see some meteorological analysis and hydrological analysis as a preliminary also for the dam optimization as well. So our main goal or objectives was not only to understand why the October and the November flood was very extreme and rare, but to move beyond post-disaster analysis toward predictive and preventive flood management, designing smarter, more resilient flood system for the future. So these are our objective, is to investigate the rare event in the October-November 2025 last year through field investigations, field survey, interview local community stakeholders, to also identify meteorological drivers, extreme rainfall pattern, storm system, climate anomalies, to understand hydrological and urban flood processes, including different things, to map flood areas, and to evaluate what intervention we should have as a hard intervention or soft intervention we should do, and to support the development of flood hazard and risk maps for dynamic and future conditions. So Vietnam and the Philippines share similar flood reality. This is one of our statements. As you can see, this is the map of Vietnam. Here's the central part, and this is Vu Gia to Bon River Basin, where we focus and the flood occurred in Vietnam. And this is also the northern Luzon Island of Philippines, where Cagayan River Basin are located with more than 28,000 square kilometer surface area. Both river basins are the champion, receiving the large number of typhoon tracks crossing the countries from since long time. And that also, the one reality is frequent exposure of this typhoon and extreme rainfall and flood as well. Another reality for characteristics, both of them are agriculture-driven system. support rice and corn production. With a rapid urbanization concentrated along floodplains and very especially in Tuguegarao area, they are living along the riverbanks, their houses. As you can see, this is the very beautiful meandering river, and the people or the city located just within the floodplains. So at the same time, they have also regulated upstream system through multi-purpose dam and hydropower dams. So in October 2025, I will start with the central Vietnam, our field survey, because we fly from Japan to Vietnam first. Then in the Vuja-Tubon River Basin, it's experienced a record-breaking rainfall that triggered widespreading flooding. While the basin had already suffered historical floods, as you can see from this flood inventory, different events with different rainfall intensity and the damages and the loss, human loss. But October, November flood, as you can see, reached to unprecedented level with a daily rainfall at Bash Ma station in Hue City, peaking 1,739 millimeter in a single day, which is a very new record. So this rare event, according to the official, reported a large number of damages and human loss as well. So based on our questionnaire and our data collection with the local farmers and the local residents, we understood, the lady told me, she lifted her hand and she said the water suddenly increased from my leg to over my hand, almost reached more than 2 meters in a couple of hours. This initiation of fast increase of the flood is really very triggering for us, because usually they are familiar with the flood. What happened this time? So we tried to see the hydrological monitoring for water level in the river, in the downstream. And we found that, of course, this is a very rapid increase. We can see with more than 2 meters reached in a very couple of hours, 4 hours or less. And additionally, we found that also the several dams exist, but a kind of ineffective operation or human decision with a kind of wrong operation release of the dam aggravated the flood very severely. So you can see, I will explain this in detail later on. So we first started with these beautiful maps to show the precipitation pattern are shifting. And this maximum rainfall intensity has increased, especially in the central part, as you can see here. And these indices of maximum 1 day precipitation, maximum 5 days precipitation, confirm stronger short-term and multi-day rainfall extremes. And additionally, the trend map showing the widespread increasing trend over all country, indicating also more intense and less predictable precipitation compared to the historical condition. That was our first understanding. Then we tried to understand why this rare event or this rare extreme event occurred. We tried to analyze the large-scale climate drivers, and we understood the period was characterized by a strong negative Indian Ocean dipole and the La Nina conditions, which enhancing the warm sea surface temperature, SST, around the southeast Asia, as you can see in the map in the middle. At the same time, a negative Antarctic oscillation, also known as negative southern annular mode, shifted the subtropical jet stream equatorial and weakened the circular polar wistereals. So this configuration also shown here that the warmer than normal CSST around Southeast Asia enhanced also the atmospheric moisture content, and the IV transport, or the integrated vapor transport maps, confirm the strong moisture flux toward the central Vietnam. So they have these two winds converge, and the central part combined with the low pressure system and persistent convergence in the middle. And this led to a sustained heavy precipitation in October and in November 2025. Okay, sorry. So we tried to, already we had our models, hydrological model and the hydrodynamic model. We built, of course, before the event, because we are working now since 10 years or more for this area. Then we tried to use our calibrated and validated model, hydrodynamic, because we need a very detailed flood map or flood depth, where and how much the inundation depths occurred for each area, urbanized area, agriculture area, and different areas. Then we could see and simulate the flood inundation of October 2025. So here we compare the simulated inundation from our validated HECRAS model with the observed satellite-based flood extent in October 2025. So this showing a strong spatial agreement across the floodplain, and this means our model is working fine. Then we tried to see the issue about the dam release, as I explained, and what happened, and why this onset initiation of flood increase in the peak reached in a short couple of hours. So this map shows the Vuja-Tubon basin, and they have several hydropower, but there are the largest 4 hydropower exists, as you can see here. And one of them, the largest, is Song Tran 2 reservoir, which has more than 520 million cubic meter. So the reservoir is mainly designed for hydropower generation with downstream flood control as a secondary purpose. But what happened for this, we will see during the typhoon or during the extreme rainfall. We can see that this is the water level in the reservoir. There is no pre-release. Even they have a couple of days before the dam, they understand there is a very extreme or the rainfall are coming, but they didn't conduct any pre-release. They continue storing, and then suddenly they are increasing the water storage. But surprisingly here, they stopped release even during the peak flood is coming. That was a very ineffective operation for the cascading dam system. So you can see the red color. This is the release from the dam and the reservoir inflow here. And there's a triple peaks successively reach at the same time after the first peak. Then we tried to do some optimization, and we tried to suggest a concept for pre-release 6 days ahead. Through the turbine, then they are able to generate electricity even in this short period with a higher recovery, and at the same time they can cut the peak, flood peak from 5,000 to 2,000 cubic meter. So it means that the win-win hydropower generation maximization and at the same time reducing the disaster risk reduction in the downstream is possible when we conduct the pre-release concept 6 days ahead. Of course, this is required a very accurate rainfall prediction in advance. Okay, so we began our field survey in Vietnam by engaging with the Da Nang local authority and flood management agencies, and as well as the Smart City Operations Center and the university partner to ensure our coordination. And when we go for each country, we have a very strong collaboration with the local authority, local governments. So like that, we can listen with the real story before we start our field survey. We collect the data, we understand where are the hotspot area, then we started our field survey. But we understood, interestingly, Da Nang City, they established a smart city application, which is very effective, that the local residents, they can send some warning or rescue request. They can send if they have any trouble for receiving a rescue from the local government, as well as this application will help for different purposes. For decision making, they have another application as a platform to integrate between different stakeholders. So in Da Nang, we conducted this detailed post-flood survey by measuring high water marks and multiple locations with a record depths ranging from 1.5 to 3.5 meter inundation depths in some areas, as you can see. So these field observations were combined with the community questionnaire, and we really learned a lot during this from the questionnaire and interview with the local residents and farmers. So many reported, as I explained, that the water rise limit warning time for them and the repeated flood impacts on their crops and the livelihood. So their feedback highlighted both the physical severity and of the event and the urgent need to improve the coordination, drainage capacity, and the early warning system. Through the interview with the local household, residents reported this onset, and also we could understand another interesting things, that the local people, they have 2 floors. The second floor, they are using mainly for flood to move their assets and things from the first floor to the second floor. But during last flood, it was a little bit tough for them to do that strategy. So Da Nang also has modernized their flood monitoring system, replacing the old manual gauging with real-time smart sensors to enhance the early warning and reduce response during extreme events. This is our key findings for Da Nang post-flood survey. I will skip for the time. So we replicated the same what we did in Vietnam with the field survey and multi-level stakeholders meeting in Philippines, for especially in Cagayan River Basin. Cagayan River Basin, they have only one large multi-purpose dam, Magat Dam, as located here, and they have another several small agriculture dams. So during October, November 2025, northern Philippines was hit by this successive typhoon. Several typhoons within a short period, 3 typhoons from October to November. So this feels like we say déjà vu in French. So satellite rainfall data showing the typhoon during 1 and 5 years ago, Ulysses. Ulysses typhoon 2020, it was the same successive typhoon and the same damages for the same area. And you can see here the video showing the inundation at the Bonton Bridge reached to the more than the warning level. We already did a very detailed analysis for Ulysses typhoon, and we saw the successive typhoon. During Ulysses or 2020 typhoon, 7 successive typhoon within 1 month and a half. And we understood the analysis or the spatial distribution of this rainfall. We also conducted RRI modeling to understand the hydrological simulation and understand the inundation depths as well. And we have the flood hazard map, detailed flood hazard map along the Cagayan River Basin at these areas. We conducted the high-level engagement, ensured that our technical assessment and directly connect to the city and the professional province, the professional decision-making at the Isabella province. So then we had our field survey as well, and we could see, of course, the big difference. They have a very one staff just to collect the data, no real-time monitoring as we saw in Vietnam. So our ground survey documented flood depths exceeding almost 3 meters in multiple locations, providing critical validation for the basin-wide flood impact assessment. So the dam, how the Magat Dam performed during that flood. Fortunately, because of using the pre-release concept, Magat Dam started pre-release earlier before the flood came. Then they can release only the minimum and they cut a large peak within the dam. But still, one point, based on the questionnaire from the local farmers, they said, okay, Magat Dam, they did a very good job with the pre-release. However, they have another things because there are almost 22 tributaries joining the main river. When the Magat Dam release, the other tributary cannot release the inflow, natural flow, because already the main river is very high, so backwater effect will be occurred and the inundation reached to more than 2 meters in some of these tributaries areas. This is also very interesting phenomena. That's why we tried to do a coordinated multi-dam operation basin where we tried to propose almost 20 dams along the basin in order to reduce the flood in the Cagayan River Basin. So this is my final message. Our proposed framework is built on these 3 pillars. The basin-wide monitoring and observation are really very important. Smart governance and digital decision support, context-specific structural hard measure as well. With this, I would like to thank you all, and I would like to thank my team at Kyoto University. Special thanks for the post-flood study teams from my lab. And with this, I would like also to thank Natural Disaster Research Council, where supported us for the field survey fund, and the Nexus Philippines from JST. Thank you very much. Thank you.